Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and let's solve it together. So today I will show you two methods to solve the problem, starting from the recursive way, okay, and going to the recursive DP. Both I will show, and the very interesting thing about this problem is that the time complexity. You might be expecting that the time complexity will be exponential in recursion case and it should give a TLE, and for DP it will be correct, but it is not so in this case. Okay, we will explain in detail why it is happening, so definitely stay till the end of the video. The time complexity analyzation case is a really interesting one in this problem. So let's see. First, try to understand the question at first. So length of the longest diagonal V-shaped diagonal segment. You are given a matrix which will contain only 0, 1 and 2. Okay, so what you should do, you should select a path, also known as segment. So it should be V-shaped. What does it mean? The path should always start with 1. Okay, so if there are multiple ones, you have multiple ways to start your path, and the subsequent elements should follow this sequence 2020, and it may stop at any point, right? So what is the sequence that you can follow? You have to start with 1, and then the sequence which you have to follow is 2020, and so on. Okay, and you can stop at any point. Let's say you stop at this, then the total length of your path is this. Okay, so it is a 4 length path. This is a 4 length path and you need to return that length. Okay, so the segment, it starts along a diagonal direction. So in order to visit elements in the matrix, so how you will go, you can traverse along the diagonals. Okay, you can traverse along the diagonals, but wait, you traverse along any diagonal? So see, the restrictions are given here. Start along a diagonal direction, okay, and continue the sequence in the same diagonal direction. Make at most one clockwise 90-degree turn to another diagonal direction while maintaining the sequence. Okay, so what you are allowed to do here is, let's say you in a very big matrix is there and you find a 1 somewhere here, so and you decide that maybe I will start with this 1. Okay, and so what you do, you choose any one of these 4 diagonal directions. Okay, you choose any one of these 4. Let's say for instance you chose this direction you chose. Okay, so what will you do, you will find for a 2 here. If there is a 2, then only you can choose direction. Okay, so it will start with 2, it will start, then it must have 0, it should not have 2 again. Okay, so it must have 2 again, and 2020 should go on. But now at any step you can also take turn. Okay, so let's say this turn you take. Okay, you can take a single turn. You could have also taken, instead of going here, you could have also taken a turn here, then you would have expecting a 2 here and then 0 here and 2 here. So you are, it is just asking you that what is the longest length of this whole sequence you can cover. Okay, so if you see the example also, you see it is starting with this particular one. Okay, and it is going to the bottom right, and it's going to 02020. Okay, it is taking one turn here and the turn should be 90-degree clockwise. Okay, and you see here it is first going the bottom left, and then again it is taking 90-degree clockwise turn to get 202. Okay, so I hope this you can understand, and it is told that you can take at most one clockwise turn. It means that it is also possible that you do not take any turn. So if you do not take any turn in this example, you see 2020, this is the case where not taking any turn is also giving you one of the maximum values. So you need to return the maximum value. What is the maximum length? You see there are 5 squares highlighted, so the maximum value is 5. The output should be 5. Okay, so that's what you should need to count the initial one also. So how should you do it? Okay, so definitely the first thing which can come to your mind is that at each step you are having some options, right? Let's say at the first step you are having options to choose from one of the 4 directions. Once you choose a direction, you have options whether in the second step, this is the first step, now you think of the second step, you have chosen one direction, then you can choose that whether you want to stay in the same line or you want to take a turn. Then in the third step again you can also choose again. Let's say you chose that you want to stay in the same line, then you again can think that whether I still want to stay in the same line or can I take a turn. So isn't it looking similar to something take not take? Yeah, definitely, right? Take not take kind of recursion value. So it is something like either I will take a turn, I can take a turn, or I will not take a turn. Okay, so now definitely I can set some flag which will tell me that if I have taken one turn, okay, so if I am taken one turn, I am not allowed to take any further turn. Okay, so that I can take care of that. Okay, so it is looking something similar to take not take DP, right? And take not take recursion. So I can write the recursive way, and then I can also memoize it or write the what is known as recursive DP. So I have also taught how to convert this recursion to recursive DP in detail in one of my DP playlists. The link you can find from description. Okay, so in that playlist I am teaching DP from very basics to very advanced. Okay, so you can just follow that. I have already taught how to convert recursive to recursion. Anyways, we will see in this video also. So I will first write this recursion solution and then take this recursive DP. So another thing which you need to analyze is that how will you call out about these directions? Okay, how will you instruct your states to take these directions and so on? So you see there, this is, let's say this is J. Okay, this is the matrix and this is J and this is I. Okay, you can take some directions, right? In the four directions, what are those directions will be? So let's say this is the J direction, this is the I direction, and you are in the cell I comma J. If you take this direction, what will be your next cell? It will be I plus 1, J plus 1. Now if you take this direction, what will be this? This will be I plus 1, J minus 1. Okay, if you take this direction, it will be nothing but I minus 1, J minus 1. If you take this direction, it will be nothing but I minus 1, J plus 1. So you see, you are adding some minus 1 or plus 1 sequences, right? And you need to take one clockwise turn. So if initial direction is this, you can go to this direction at max. If initial direction was this, you can go to this direction at max. So that is what is happening. So you can set a direction vector. Okay, so if you already know BFS on grid, that's a very common thing which we set the directions in this manner. Okay, so what we do exactly is that we create a 2D vector. uh, we will call it 1 comma 1. It signifies this one and this one, what we need to add to the I and J values, right? This signifies one particular direction. Let's call it direction 0. Okay, because it is in the index 0. Okay, so we have it 1 comma 1. You see what is the next thing? 1 comma minus 1. You see what is the next thing? Minus 1 comma minus 1. You see what is the next thing? Minus 1 comma 1. Okay, so this is nothing but your one direction 0, direction 1, direction 2, direction 3, and this is corresponding to this 1, 0, 1, 2, and 3. These are your directions. Okay, so every time you change one direction, you can do direction plus 1. Okay, so let's say you are in this direction right now. If you do plus 1, you will go to this direction. But wait, if you are in the last direction and if you do plus 1, where will you go? So you do direction plus 1 module 4. What does module 4 means? It tells you what is the remainder after dividing by 4. So that can go from 0 to 3 only, and you need 0 to 3 here. So the direction case you can handle. I will again explain this while I code. So I hope there is not much difficulty in this. So you can just do direction equal to direction plus 1 whenever you decide to take a turn. Okay, so definitely what are the variables you need? What are the states of the recursion you need? You definitely need an I, you definitely need a J. Now you understand that you need a direction also. And wait, you need another bool value which will tell you whether you are allowed to take a turn or not. Okay, whether you are allowed. So it can be true or false. At first it will be set to true because initially you are allowed to take a turn as you are traversing. Initially you can take one turn. Once you take a turn, you set this value to false. Okay, so you can just set this value to false, and the remaining same thing, if you have already done this take not take recursion, you should be able to do it. There should be no difficulty in this. Okay, so I will just code this out. I will show the recursion code first. So uh, at first, what do I need to do? I need to start see my starting point, right? And you can, as you can see, my starting point is giving me 4 choices. Okay, so I will just go, and starting point must always be 1. So let me keep an answer first. I will maximize the answer, and I will also have some m and n. So let's say I have this grid dot size as m dimension, and I am calling this grid of 0 the as the second dimension. Okay. So what will I do? I will definitely iterate through the array. I will go from 1 to m. Okay, so this is 0 and I plus plus, and again for the second dimension I will traverse from j from 0 to n, and now I will check that I can start from a point or not. When can I start? It's quite obvious that when the grid is 1, my statement starts with 1. Okay, so when the grid is 1, I can now start. Okay, so I can just start from here. So now how can I start? Initially at the starting point I can take any four directions, so I have four choices again, right? I'm having four choices again, so I will do another loop. Okay, this loop will only be of size 4, so it won't affect that much in your time complexity, right? So I hope you can understand. I just took all these four directions. It will go from 0 to 3. Okay, and what will it tell you that try from every direction. Okay, try uh, updating this answer. Try updating this answer from every direction. So I will write another function, find, which will give me the value, which will just traverse in that direction and perform a take not take recursion and give me the value. Okay, so what is this find will give me? It will give me the length of the segment. So what will it pass? It will pass grid. Okay, and as I told you, it has ij, it has direction, and it also has a bool value which is initially set to true. As I had already explained you the states of the DP, right? I will call it allowed. So these are all the recursive states. Okay, now you see, you need to find the length of, now this should start with 2020, right? And another thing, what value you are expecting, that also you must take account, because you are expecting only a single value, right? 2020, only a single value you are expecting. So after 2 you are only expecting 0, not 1, not 2. After 0 you are only expecting 2. So you can also, so every time you keep a target value, that what is my target that I am expecting, and I can flip that target. So initially the target will be 2. Okay, how can I flip that 2 to 0? I can do 2 minus target. What will it give me? It will give me 0. Okay, so again if you do 2 minus target, it will again give you 2. Again if you do 2 minus target, it will again give you 0. So you can flip it in this way. So yeah, another state you definitely require, which is target, but initially it definitely starts with a 2. Okay, so because the starting sequence, you see, the subsequent elements which follow must start with a 2. So I hope you get it easily. And initially you have 1, the length of 1 is, you are also counting it, right? So you see, there is 2020. There are only 4 elements, but one you are also you are counting. So I will just add 1 to it, and definitely I will update my maximum value. I will update my maximum answer with this. Okay, among all the 4 directions, whichever is giving the maximum value, I will just update it, and at the end, definitely I will return answer. But I need to write this find function, right? So yeah, I will definitely write it. So let's go ahead. And well, just a second, as I told you, I also need a directions, right? So this directions is nothing but a vector of this, as I already explained you. So you can keep a vector of integer direction. Okay, so I'm writing full, and it will just give you the exact same thing, 1 comma 1. This is the same thing, 1 comma minus 1, then 1 comma minus 1, and then it has minus 1 comma minus 1, and then it has minus 1 comma 1. Okay, so this is the directions. Okay, direction vector. So I will start with this recursive approach. So this is definitely a recursive function, as you can understand, and it takes the first argument to be a grid. We will definitely pass that by reference, and it has I, it has j, and it has a direction. Also it has a boolean value which will tell me whether I am allowed to take a turn or not. Initially I am allowed, so I am giving it to be 2, and this is my target. Okay, so what value I am expecting next in my sequence. So what should I do initially at first? So initially I am not in my current cell, right? I am in my first cell, I comma j. I started with I comma j, which is at 1. So initially I should take a step and go to the next cell. So new I and new j is something which I should go to. Okay, new I and new j. Okay, so after you go here, you see what is the how the value will get updated. I will get either +1 -1, whatever be the case. It is depending on which direction you are traversing. So why I created this direction vector will be now more clear to you, is that this is the first index. Whichever thing I need to add to my I, this direction will decide me in whichever direction I am moving right now. And this will also give me the same thing, directions of direction. You go to this particular direction, you go to this, let's say you're in the second direction, this 0 1 2 3. So in the 2 direction you will go to this element and add a -1 to both of them. Okay, you move into both I and j. So you got the new I and new j right now. Okay, now you need to take care that these do not escape the cells. Okay, so what do I mean by escaping the cells? What if you are, let's say you started with 1, right? Let's say 1 was here and you are taking a step here, then you should return 0, right? Because you are moving out of the cell. Or if in any time you are 1 here, you can't just take a step which goes out. Okay, so you must ensure that you are staying within the cell. So what are the things you need to ensure? So ensure you are staying within the cell, staying inside. Another thing which you need to ensure is that you get the target. You get the target, otherwise also return 0, because it's no use, right? So after 2, what is the target again? If I remind you, it's 2020, whichever value you are expecting. Okay, so that's the target. So uh, let's see now what to do. So I shall just take care of the bounds. So this should be less, if this is less than 0. Okay, or if this I is greater than or equal to m, or this j is less than 0, or if this j, new j, is greater than or equal to n, or see, in all of these cases the bounds of the grid are exceeding, right? You are going out of the grid. So if you are going out of the grid, or you see something like grid of I, new I and new j is not giving you the target anymore. Okay, it is not giving you the target anymore. Then what to do? You should return a 0, because you should stop your path right away. Okay, you should stop your path right away. You will get no more a length of the path. Okay, no more you should get a length of the path. Oh, and this will be nothing but your base case of recursion, as you can easily understand, right? And okay, now the base case is done. Now there should be two variables, as I told you. Take turn, if you are allowed to take a turn. Okay, take turn, or int not take turn. Okay, not take turn. So I am having two variables. So I will first tell that if you want to remain if you want to go straight, keep going straight and not take a turn, then you should think of something, and you should think what will happen if I take a turn. So if I am not taking a turn, I do not need to check anything. I can just go to straight. Okay, I can just keep going straight. So if I just keep going straight, what will happen is that I will get one length. Okay, since this is not 0, it means that I am in a valid cell and I get one answer. Okay, I get one. And find, my next state will be find. I'm writing, since I'm writing recursion, this grid will be grid I, new I and new j this time. Okay, the values which I have calculated, and the direction will remain same. You are moving in the same direction. You have not taken a turn. Okay, you are not taken a turn, so you are in the same direction. And you allowed to take turn? Yes, you are still allowed to take a turn. Okay, you are still allowed to take a turn. And your target, what should be your target? Okay, now if you are in 2, your target should be 0. If you are in 0, your target should be 2, right? So the target should be 2 minus target. Okay, so I hope that is clear to you. I already told you that how can you flip the target. Okay, so if the target is 0, it will go to 2. If the target is 2, it will go to 0. So that's how you can flip this target. And yeah, this is the thing when you decide to not take a turn. Now what if you want to take a turn? So if you ask me that if I'm allowed to take a turn, then only I can take, right? So if I'm allowed to take a turn, I can just do something like find grid. Okay, new I, new j. Okay, but the direction will get flipped. As I had already told you, if you decide to take a turn, your direction will be nothing but direction plus 1 modulo 4. So you just go to the next clockwise direction. I have already said these direction in a clockwise fashion, so you just go to the next clockwise direction. Okay, and you are now, since you have taken a turn, you are not allowed to take a turn. So I did just not allowed. So okay, so if it's true, it will turn to false and it will never be entering in this if statement. So and definitely 2 minus target is still holds because the alternating pattern should remain. It should definitely remain. And while returning, what should you return? You should return this maximum thing, right? If you, let's say, maximum of take turn and not take a turn. Okay, so I hope this is very clear to you. So you just take in every step you are just taking asking yourself that whether you can take a turn, then take or not take. Okay, and among whichever is the maximum value, you just return them. You just return them whichever is the maximum value. So if you try to run this and check if it works or does it has some error. So you see use of undeclared identifier m. Okay, so I do not have the m here, I have it in the different function. So this will be grid dot size, and for the second dimension it is nothing but grid of 0 dot size. So if you try to run it now and check if it works, so you see we are getting a wrong answer. So I will just quickly check where is the mistake. So you see take turn, when you are taking a turn you also need to add 1. Okay, so I just missed it there, and let's see now. You see you do have the accepted thing, but if you are taking or not taking a turn, what will you expect? You will expect a TLE, right? Because you will expect an exponential time complexity. But if you try to submit it, and check, even for 561 test cases it is passing very clearly. Okay, even the recursive approach is giving you accepted. Nevertheless, we will explain this time complexity. Why is this time complexity still passing even if I am doing recursive approach? But first we will try to write the DP approach. So in order to convert from recursion to memoization or recursive DP, I hope you already know the approach. You just need to initialize a DP. So what are the states of this DP? Definitely you might be thinking that it is I, J, direction and allowed and target. But you see every time the target is of a single dimension. Target is either 0 or 2 and it can be taken from the previous state. So in the unique state you do not have two choices for target. In a particular state you only have one choice for a target, right? And it will remain it can be derived from the previous value. So this is not a repeat state, so target is not a DP state. The states of the DP are I, J, direction and allowed. What are the maximum values of I and J? If you look at this values, it is 500. So I will write the DP as 500, 500. And what are the directions? There are 4 directions because initially also you are having the 4 directions. So maximum you can go to 4, and since this is a boolean value, there are 2 values only allowed. Okay, so you see a DP initialized in this way, and you memset this DP. What did I mean by memset? If you know memoization already, so I have already explained it. You just set -1, meaning that in your recursion you are telling that these states are not visited right now. Okay, and if it is not -1, so how can I tell that? If this new I, new J and this direction and this allowed, okay, this whole thing is not equal to -1, okay, just return this thing. Okay, so I hope you understand this. It means that if it is like a catching, right? So you are catching the values, and if you are seeing that it already has some values, that do not recalculate your previous states. That's how you save the time complexity in DP, right? So you do not recalculate your previous states, and you just return it right here. You do not need to go ahead in your function. And if this is -1, then fill this state, and then you must save the state also. So how can you save the states? It's very simple. You just have this direction, you have this allowed, okay, and you just save your state to this max, whatever value you are returning. Okay, so instead you just save the state, and next time you do not recalculate your states, because in recursion you might be recalculating stuffs. Okay, So yeah, that's all for the memorization. If I try to run it and check, uh, does it, you see it gives an accepted case. Now you think that it should improve the time complexity at least a little bit. So if I try to run it and check, uh, yeah, it does definitely increase your time complexity, but not to that great extent. I mean, it is 80% base, that's correct, but the question now comes that why it is passing for both. I mean, why is it also passing for recursion as well as memoization? Doesn't recursion have an I mean time complexity which is exponential? So you see here there is no actual exponential time complexity. This is a very interesting thing, that because in both of this recursive approach, okay, and this DP approach, recursive DP approach, both of this time complexity is nothing but O of m into n. Just you are saving some of the states, so you are doing some benefit by doing DP, so that's why. But that's why the bits was greater, but this recursive approach is still m into n. Why? Because uh, you are thinking that every time you are having two choices of taking a turn or not taking a turn, taking a turn and not taking a turn. So you might be thinking you are having two choices for every time, and so if there are m cross n cells, you are might be thinking that you are having some exponential time complexity. But you see, let's say you decide to take a turn here, and let's say you take one turn, then you are not never allowed to take any further turns, right? So once you take a two decision whether to take or not take, you always have a single path. Okay, you always have a single path. One, so if you are taking not taking a turn, you are going here. But every time when you are not taking a turn, then only you have a choice of taking a turn. Once you take a turn, you have only one real path. So if you look at our choices, what are our choices? It is not take at every step. It is not like this. It is like this. You can take or not take. Okay, but for everyone it is one. Once you take a step, you have one. So if you do not take a step from the first choice, okay, so if you are telling that my first choice I am not taking a step, so that is one choice. And let's say in somewhere between you are taking a step, you have two choices there, and then from next onwards you have one choice again. So you see, and every state, you see every cell, this, if this is I comma j cell, you every cell of the state you are visiting only once, okay. And if there are m cross n such cells, and for every on choices also I showed you that there can be at most two choices at once. This is not true, these things are true here. So that's why the maximum worst case of time complexity should be 2 O of 2 into m into 2 mn. Okay, so that is what is happening in recursion. That is why the recursion approach was also passing without the DP approach, right? So yeah, I hope you understand, and I think I was able to make this a little bit interesting. So yeah, that was all for this video, I guess. I hope your day goes really easy. Thank you so much.